Okay. Okay. I'll record the session, guys, so that those who are struggling to connect can go through the session when they get time. Uh, but yeah, I'll send it through to everyone who is actually who was supposed to attend this meeting. Right. So let me begin now. Okay, let me begin. Can you guys hear me? Can we proceed? Okay, guys. So I'm recording the session now. I'm gonna share the recording when I'm done, so that those who are struggling with connection issues can like go through the video and cover everything. So, can you guys hear me?
Yeah, I can still hear you by my side.
Okay, amazing. So those who are not, those who might not hear me, I'll send the recording to you guys, and then just if you struggle to join because of connectivity issues, please send me your banking details. I'll send you guys money for data, and then you buy data and you hotspot yourself like that. So if you're struggling with Wi-Fi, UJ, or Wi-Fi UJ, just let me know, and then let me know how much your data costs, and then I'll send you money to buy data so that you can join and attend like that. Okay, cool. I'll proceed now. Um, Let me just proceed. So, moving on to how do we read our practical or our semester test? There's gonna be two different versions of this. So I already shown you guys. Let me just open also practical 9 so that you guys see how these pracs will be how different they are gonna be from one another. Practical 9. Yeah, so I'm gonna open this practical side by side, and I want you guys to look at something. So I mean, you can prepare for practical 8 and you can prepare for practical 9, but at the end of the day, it's like gonna be random which paper you are gonna get. If you look at the differences there's some similarities and differences between these two practicals, right? The differences are, let me just start with the similarities, right? The similarities is that they both have similar methods. Initialization is there, movement, here they call it movement, here they're saying moving. Then there's update, then there's end simulation, there's also end game. You see, so this one is a simulation, this one is a game. So please take note, keep that in your mind, that there's gonna be a simulation and there'll also be a game, right? And it's either you flip a coin on if whether you're gonna be getting a simulation or you're gonna be getting a game. So what the smart people do, they obviously prepare for both, because you're not sure if you're gonna be getting a simulation or you're gonna be getting a game. So as soon as you get your practical, your mind should tell you, damn, I now know that there's gonna be a game and a simulation. What is this? Have a look at the questions, or just scroll through during reading time and just say to yourself, damn, this is a game. I'm gonna approach it using the gaming logic, and damn, this is like a simulation. I'm gonna approach it using the simulation logic. You see, and then the if you look at the rubric, exactly the same. Everything looks exactly the same. Nothing different here. Same thing. C0 till C10, then there's B. C0 till C10, then there's B. They all look exactly the same. But then what you might have not realized is that the other one is a simulation and the other one is a game. So know which one you have as soon as you get your paper, and then apply simulation logic if you have a simulation, and then apply gaming logic if you have a game, right? Okay, cool. So now let's look at the major differences between these two practicals, right? If we look at practical 9 and practical 8, we're gonna go through initialization. This one is short, this one is a bit long. Movement, this one is a bit long. Also here it's quite short, and then the update is short, this one is more, you see. And then the end simulation, it's more detailed. This one, it's obviously less. So you must keep this in mind, that you're gonna get something like this, and you should be able to tackle it appropriately. So let's go through practical 8 together, right? So practical 8. The purpose of this assignment is to introduce the type of problems presented during the semester test 2 and exam. So 2022 exam paper A. So you can see this is paper A. So paper A 2022, it was a game, right? And then obviously they're just saying here, do not plagiarize, do not copy people's works. You know, you must do your own work, which is what I want to try and make you guys understand. I want you guys to be independent. As soon as I'm done tutoring, I want you guys to be independent. I want you guys to say, I can read this on my own and I can do it on my own. You understand? So, right, let's look at there's like gonna be some story. They're gonna read you guys a story, or you're gonna read during reading time. You just read the story just to get like an idea or to paint a picture in your head of what's going on. So they say that the Raiders of the Lost Ark, right? And then they say you have been chosen to assist a team of treasure hunters in finding a lost ark, right? So don't overthink this story. Don't try to think now, oh, how am I gonna code this? I have to find a lost ark. Nah, just read it as a story, and then don't obviously dwell much on the story. Just have like a picture or an image of what's going on. So a treasure map has to be reconstructed to find the lost ark. The problem is that the map has been ripped into pieces. The pieces have been scattered across the mighty utopian jungle. You need to write a simulator game that will teach the treasure hunters how to search for the map pieces using the latest utopian drone technology. Right? So you have your grid, right? What is a grid? A grid, a very very important question. What is a grid? A grid, it's like a 2D a 2D square that has like rows and columns, right? So if I do this, let me show you guys something cool. This is a grid. I'm surprised I was doing CSS today. So this is a grid, right? So it basically has rows and columns. So this is a row going this side, and there's a column going down, right? So, but this is not what I wanted to show you guys. If I do snake game grid, yeah, if I do a snake game grid, let me just go to images, right? You guys know that snake game is it is a grid, right? If you guys have used old phones where there was a snake game like this, right, you might have realized that it's a grid. Even now they've added some animations. The snake has like it moves in like it's no longer a grid anymore, you know, it has shape and everything. But then the fundamental is that there's a grid, and then that grid has it has basically your rows and your columns, right? So your rows and your columns, and then there's gonna be your snake, right? So now if you look at the basic snake game, I'm just gonna show you guys this one here. Yeah, so if you can see my screen, if you look at the basic snake game, right, you will notice that there's gonna be rows going this way and columns going down. So this is row 0 column 0. This is row 0 column 1, row 0 column 2, going for, so and so forth and so forth. Going to this side, it's still row 0, right? And then going down, this is now going to be row 1 column 0, row 1 column 1, row 1 column 2, etc. going. So you must keep that in your head, that there's going to be a grid. And what is a grid? A grid is basically rows with columns, right? Okay, cool. And then so this is what they're showing us here. This is your grid. There's going to be row. I'm just going to write that down. Row, and then there's also going to be something called column. So all right, so now given that we have a row and a col, so what do we know about this first cell here? So this first cell is basically row 0 column 0, right? Because it's 0 and then column 0, and then this is going to be row 0 column 1, row 0 column 2 going this side, right? So keep that in mind. We're going to be working with grids, and we need to understand rows and columns. Okay, and then now inside our grid we have entities. We have things here. These axes, these triangles, these dots. It's basically the things that are inside our grid, right? We need to understand them as well. So what are the things inside our grid? They did put them here. There's gonna be a player, which is the black circle. There's gonna be a tree, which is an X. There's gonna be the scan range, which is the large circle. There's gonna be map pieces, right, which are the white circle. This is a map piece here. There's gonna be charging towers, which are these triangles, and then there's gonna be empty areas, the empty blocks, which is has nothing. So you must know your entities. You must know all your entities before you actually come to do your initialization, because they're gonna be important when you do initialization. So now your pilot, you pilot a drone that flies over the utopian forest in the game. The drone has a specific charge, right? So the drone has a specific charge, and then the drone can recharge at charging towers, blah blah blah. So you're just gonna read this just to understand the scenario, what's gonna happen, right? So hidden in the trees are the map pieces. The drone can scan the specific area and uncover any features hidden underneath the trees. The drone can collect the map pieces. When a map piece is found, the game ends. So this is another important thing. When does the game end? When the map piece is found, the game ends. When the drone has found all the map pieces, so no, they're saying that the game ends when the drone has found all the map pieces or the drone's battery runs out. So basically there are two things that will end your game, which is basically you have run out of battery or you basically found all the map pieces. So just like in a snake game, the game ends when you bite yourself, or if there's a wall around the area or around the world, when you hit the wall, the game ends. And then so now let's see, the game has found all the map pieces. So either you found all the map pieces or the battery runs out. That's when the game that's when the game ends, or the battery runs out and crashes into the trees. So if you hit the trees and then you run out of battery, basically the game ends. So you must place the logic in the forest space namespace. This is also important. You must highlight this one as well, the namespace that you're gonna use, right? And then we come to the initialization. Initialization, they're saying that the size of the environment. What do you guys understand about the size of the environment? What is the size of the environment?
Isn't that the size of the grid, like in terms of columns and rows?
Definitely, amazing. Yeah, the rows and calls, that's the size of your environment, right? So the size of the environment, when they say the size, they didn't really explicitly say that here, the rows and the calls. They said the size of the environment. It's like a trick. So you know that the environment has rows and calls. You're gonna put that in, and then the chance of the charging towers getting destroyed, right? So the size of the environment, rows and calls, the chance of the charging towers getting destroyed, right? Chance of the charging towers getting destroyed. I'm just also gonna highlight that. And the number of map pieces are given as a command line arguments, right? Here's another thing that is important, the command line arguments. You guys remember we discussed the command line arguments. So how many command line arguments do we expect to see in our program?
Is it not 5 so far, because it's gonna be 1 at the prog size of environment, which is 2, and chances of charging towers getting destroyed, that's 4, and number of map pieces, that's 5.
Okay, amazing. So 1, 2, 3, 4, 5. Yeah, amazing. So in total we expect to get 5, right? Because you remember there was the name of the program as well. So yeah, that's a good one. That's actually quite good.
Wait, sir, I don't understand why there's 5.
Oh, you didn't understand why there's 5. Okay, I'll explain to you shortly, but it's right when I say there's gonna be 5. Did you I'm sure you missed the part when we were discussing the command line arguments, right? Because you were having connectivity issues. I'm gonna go through it, you'll understand. Okay. And then they're saying now that the world is filled with the following the world is filled in the following order entities. Okay, we're gonna discuss this part after. Let's just do initialization function and get it out of the way. I'll also explain the command line arguments for Kazimolo who didn't get it, and by the time we're done, we'll understand why there's 5 here. So I'm gonna go back to code block C++, right? So Nonkazimulo, what I've covered so far was this int argc, char pointer argv, right? What does that mean? What are these arguments actually? These arguments argc, Nonkazimulo, is basically it's the number of the arguments that are gonna be passed in the program, right? And then argv is basically your variables. What is actually passed? What is actually passed? So if you look at argc, what's inside argc, right? If I now come here and do cout argc, let's just say argc. So if I come here and I do cout argc and then I say argc and then end line, right? End line obviously to move to the next line. Right, what's going to happen is that we are going to see what's inside, how many arguments are passed into our program. So I did mention that the name of the program. So when you are running your program, you are giving it to, I don't know if it's the processor or what, but you're giving it to something and say, please run this program for me, right? So let's say, for example, our program is an orange, right? And then you give someone an orange, you say, please run this program for me. That orange is the exe file, what's compiled. So you're saying that the only argument that you are giving that person is the program, is orange.exe. But in this case, the program is basically our exe file. So if I come here, let me just remove if there was anything here. I'm just going to remove this for now so that I explain argc and you understand everything fully. So if I run this now, you will notice that argc is 1, right? Why is argc 1? Argc is 1 because we have passed the program. We're basically saying that this program here, this st2r.exe, it's the program itself. It's the only argument that is passed. That's why it's 1 argument so far, right? So if now I come and say that I want you to run, going back to the orange example, I think it might make sense to you. So now I say run this orange for me, and then take this take this color red, paint it with a red color. Now you're gonna pass in we're gonna pass in 2 arguments. You're gonna pass the name of the program, which is the orange, and the color, which is basically the argument. You're basically saying that I want you to paint it with a red color, right? So now we're gonna have 2 arguments, which is the exe file and also the color red, for example, right? But then if you pass in 3 colors, now you say I want you to make it have 3 colors. You're gonna pass me red, green, and blue. So now we have red, green, and blue as the arguments, and also the name of the program. So at most we're gonna have 1 argument passed, and then the other things pass through, and then it's gonna increment from then on. So now let me go here to where you pass your arguments. Where do you pass your arguments? You go to your project in your code blocks, and then you go to set programs arguments, right? And then you're gonna pass, let's say you pass 10, and then you leave a space for the next thing. I pass 10 again. So now we have 2 arguments that are passed through, also the name of the program. So now we're gonna have 3 in total. So plus this and this one here. So if I run now, you're gonna see that argc is 3, right? It's gonna have 3 things, because the first one is the name of the program. If you look here, that's the name of the program, and then we're gonna have 10 and then 10, which is basically makes 3 arguments passed through.
Okay.
You understand? So now going back to the paper, right? To the paper that we are highlighting here, they are saying that the initialization, we are going to pass the size of the environment. The size of the environment is basically rows and columns. So we already have 2, and then the chance of the charging towers is now the third thing, right? So we have 3 now, and then the number of map pieces is 4. And then also remember including the name of the program. Now we're going to have 5 arguments, but then obviously we're only going to focus on the 4, right? So that's why we're going to have 5 here. So now let's do our init function together. How do we do the init function? We're gonna create a header file, right? You guys know header file. We're gonna create a header file, and as I create the header file, I feel like I should go to this section that is very important. all the way down here in the C4. Now we are covering C4 basically, right? If you do this right, you should be able to get your 10 marks for C4. So C4 says that separate compilation header file, guard conditions, inclusion of header file, appropriate content in the header file, and use of programmer-defined namespaces, which is out of 5 marks. So you're gonna come here in your code blocks. I don't know how you guys create header files, but I was that student who actually wanted to do everything from scratch, right? So I just come here and say new file, empty file. I add an empty file, and then obviously here you're gonna say yes, and then you're gonna give your file a name, right? So let's just name this file for now ujradars, right, .h. I'm just gonna name it ujradars.h, right? Then you're gonna say ujradars.h, and then I usually got an empty file when other students where they were able to create a header file using the menu. I think there's like somewhere where it says header file. They were able to do that, right? But then you can do that if you prefer that approach, or you can do it this way. It doesn't really matter as long as at the end of the day you have a header file. So here's the header file. We have 1 mark, and then guard conditions. What are guard conditions? Guard conditions is that if and def, and then ujradars underscore h, right? And then obviously if basically we're saying if the header file if not defined, you're gonna define it. So how do you memorize this? You just say if not defined, and then just define it, right? So this line here, line 1 says if not defined, ujradars define ujradars, and then end if. That's basically all it does, right? And then how many marks do we have now? We have 1, and then we also have guard conditions. Now we have 3 marks under C4. At least that is something, right? Inclusion of the header file. As soon as you do your header file, you must be able to include. I'm going to show you how to include. I'm going to come back to inclusion of the header file. I just want to stay on one screen and cover everything, and then we're going to do the rest after that. So appropriate content in the header file, we're going to cover that as well. And then use of programmer defined namespace out of 5 marks. That's a lot of marks. So you're just going to come here and say namespace. And they did give you the namespace on your prex. They said your namespace was gonna be forest space, right? So you're just gonna come here and then you're gonna say namespace forest space, and then you're gonna put everything inside the namespace forest space. You have 5 marks now. And then inclusion of header file, you're gonna come to your main, and then at the top you're just gonna include your header file, hash include ujradars.h. There you have included your header file, and then you have 1 mark there, and then appropriate content in the header file. We are gonna cover that one as we program, right? So far you're gonna have these marks, 10 marks for free. It's just 10 free marks here if you look at C4. Right, you just want to make sure that it compiles. As soon as you're done including your header file, make sure all the time that it compiles, right? So, and then also you can just, if you're paranoia and stuff, just make sure that okay, my program still runs, right? Everything is fine. All right. So far, what questions do you guys have with what I've covered? Nothing. Okay, amazing. Okay, so now let's come to the most interesting part of what is a forest space. So I'm just gonna give you guys an idea. I want you guys to have an understanding of what a namespace really is, right? So let's think of it this way. You guys have like a pencil, you have a sharpener, you have an eraser, right? Those things are functions. Think of them as they perform specific function. A pen writes, an eraser erases, and the sharpener sharpens the pencil, right? So if you have those things, you can picture them as functions, right? So a pencil, if you wanna write, you're gonna say use the pencil. If you wanna erase, use an eraser. If you wanna sharpen the pencil, use the sharpener in the pencil, right? So what a namespace is, given that we have a pen, a pencil, and an eraser, it's a pencil case, right? Guys, a namespace is a pencil case. Whatever goes inside the pencil case it's it's basically the namespace, right? So what we're doing here, we're basically saying that put all our functions inside a pencil case, right? And then you can just imagine the whole namespace as it's gonna have functions inside. So now if I wanna, let's say now I want to let's see, highlight. I don't have a highlighter inside that pencil case. It means that my namespace does not have that function, hence I cannot perform that specific function that I want to perform. Do you guys understand? Yeah. So now what do we have inside our forest space? Um, we're gonna have obviously things like our constants. We're gonna have our functions, initialize, and everything else. So let's just begin with the initialize function. I'm just gonna show you guys how it's gonna work. So here under C9, there's allocation, there's initialization, there's deallocation, right? We're gonna try and have three functions for allocation, initialization, and deallocation. So let's have allocation. It doesn't matter what you call it as long as you understand what you are doing, right? Or initialization, it doesn't really matter, right? So let me just say we're gonna have allocation. It's a void function. We don't want it to return anything. We just want it to allocate memory. So void allocation. How I name my functions, guys, please make sure that you name them how, like using your own style, your own imagination. This function does get it does get random. Another students can name it get random, another student can name it generate random number, another student can just say random number. As long as it makes sense and you are happy with it, it doesn't really matter how I'm going to name these functions. Okay, so I'm going to do initialize. I'm going to do memory allocation, and then I'm also going to do initialization, and then I'm also going to do deallocation. Right, so these functions are each worth 5 marks. All these functions. So if you do everything inside here correctly, you're gonna get 15 marks. So given that we have these 15 marks here, and we have obviously the boilerplate is given 15, 20, 25, and then this one here 25, 35, right? We haven't really done much yet, but then at least we are getting some marks, right? So for allocation, we're gonna go to here under initialization, right? We now look at initialization. What for initialization, right? Initialization, let me use S because they used S here. Initialization, what do they want? Like, what do they really want? So they want the size of the environment. Okay, what is the size of the environment? It's rows and calls. Okay, sure. The size of the environment is rows and calls. Let me just put int rows, int rows, and then int calls. Let me just wrap around here so that I don't have to scroll, so that you guys can see everything in one screen. Okay, there's int rows and int calls. Okay, cool. What else do they need? They want a chance of the charging towers. Chance of the charging towers getting destroyed, right? So I can just call it int chance, right? Because it's just one int chance. Okay, and then what else do they want? They want number of map pieces. Okay, let me just also have int num map, or int map pieces. Let me just say map pieces. Okay, what else do they want? Nothing else. This is all that they want for initialization, right? Okay, if this is all they want for initialization, what should this function return? It should return my world, because I'm gonna have a world. So if I'm gonna have a world and we have these things here, it means I'm gonna have a function. I'm gonna have a structure. You guys know what a record structure is, right?
What?
Record structure. So struct something like this: struct game world, and then this. You guys know what this thing is, right? It's basically it's similar to that pencil case, but then this one will have a variables as well. You understand? This one will have variables. So let me say inside my game world, I'm gonna have rows, and then I'm gonna have my calls, and then I'm gonna have my chance, and then I'm gonna have my map pieces, and then I'm also gonna have my the most important thing. What is it? The most important thing. One last thing that we need. Do you guys think we have we can have a game given this 1, 2, 3, 4 variables? Is it possible to have a game?
No,
What do we need?
the player.
The player, okay, player row and player column, right? One of the things that we need, int, int player row, and then int player column. But then I will cover the player row and the player column after, right? I just want to have the world for now, right? We'll worry about the player afterwards. So let me just help you guys. We need also the array. You guys forgot about the array, the grid. We need the grid. We don't have the grid as yet, right? And the grid is also going to be part of the game world. Okay, so how do we define the grid? I did see some syntax for type def, but usually those basically is pointer and then your ARY world. This is what's mostly important. If you don't have this, you don't have a game. You just have rows, calls, chains, and map pieces as numbers, right? So this is very, very important, right? It's very, very important. You need to have this. I'm not gonna open the memo for now. I just wanna show you guys how I would do this without looking at the memo, and like I'm gonna approach it naturally, like as like a computer scientist, and how I approach obviously questions that I'm given, right? So now we have our game world. So we want our initialization function to return to us our game. We want our game world when we do the initialization. So I'm gonna come here and say it's gonna return game world. You guys understand? Are you guys still following? If you are lost, just let me know so that I can also reiterate. I know now it's getting heavy, but then this is the simplest way to approach this practical aid. Anyone who's lost? Oh, you guys are fine. You guys are sorted.
And I'm trying to understand, like, the game world now, initialization is under the void allocation or what?
So now it's under the. So okay, let me just not confuse you. Let me delete this and let me delete this. Let's focus on this. Don't worry about that function. So here I'm defining function. So defining function, basically I'm saying that my forest space is gonna have a structure, game world, and it's gonna have a function, initialization. I haven't done anything. I haven't initialized yet. I'm just defining the function.
Okay.
Because we still need the implementation file, right? But there's no implementation file here. So yeah, so let's say we have initial. Are you guys following? Are you guys still are you guys still following? Are you guys okay? I'm just gonna pause a bit and let you guys digest what I was saying. So look at the screen now and try to digest what I've been saying.
So the game world initialization function, you changed it from a void function.
Yes, to a game world function. What does that mean, right? That means that we want to do the initialization and then we get the game world back instead of it just doing the initialization and nothing happens afterwards. So just to also help you out, let me do this. Let's say we have a function, right? We have a function void sum. It takes in two numbers, int a, or let me just say int a, and then int b. Right? This function, it sums a and b, int a plus b plus int b. Right? That's what it does. That's its job. If it's void, it means it's just gonna run and nothing happens. Right? What we could do, obviously, we would see out a plus b, like something like this. See out int a plus int b, and then that's it. We're just gonna get, like, maybe if we say 5 plus 5, if we call it here, we say sum 5 and then 5. It'll just see out a plus b, right? We're not storing that value anywhere. Sum was not declared because obviously C++ You need to put it at the top first and then you define it. So this is so here what's at the top, this is the declaration and this is the definition. So here you're just telling the program that I'm gonna have some, but I'm gonna do the definition later on, which is this one here. So now if I run the program, you will see that it'll just output 10, right? But then that 10 we don't know, we only have it inside the function. It only runs inside the function, and then it's gonna output that 10, right? If we didn't output, it was just gonna run and nothing happens, right? So now if we have a function, same function, but now this one is int sum, int a, int a, and then int b. This one now can return int a plus int b, right? This one has a return type. It returns, it gives us back something. This one just runs and nothing happens. It is just gonna see out. And as soon as it's done running, that's it, right? And then the second one, the difference between the two functions, between these two functions, is that this one, when it runs, it's gonna return us a value. So if I do sum 5, we're expecting to get something back. Where do we store that thing? We're gonna store it inside an integer a, because this one will return something, this one won't return anything, you understand? So the same thing applies to what I just showed you now. The initialization function is not just gonna run and then nothing happens. It's gonna run and give us back game world. After it runs, it's gonna give us back game world. So if you look at game world, right, it's gonna have things inside, right? After we run this function and then we get a game world, we expect our game world to have rows, calls, chants, map pieces, and the grid. That's why we are returning it. Does it make sense?
Yes.
Yeah. Okay, cool. Are you guys following? Are you guys still on the same? Can I continue? Can I proceed? Or do you still have more questions to ask on this topic of initialization, returning the game world?
No.
Okay, amazing. Now that we have the header file, you can't really define your function inside your header file. You have to define it inside the implementation file, the .cpp file. Make sure that you know that. So now you're gonna have to create a new file. We're gonna call it uj radar. Instead of it being .h, we're gonna say .cpp, because this is the file that will now define our code. Like, what does the function really do, right? So think of the header file as a blueprint, right? A blueprint to a house doesn't really build a house, right? How to actually build a house, there are people that you must hire and everything. So the people doing the job is the definition. This one here is the declaration, right? They look at the map and then they're like, oh, okay, cool. You want us to build a house, and then you just give us the material. This is the material, right? And then we're gonna use this material to actually implement implement the whole thing. So now, how do we implement? We implement by obviously using the .cpp extension. So in your project, you're gonna have the header file.h. You're gonna have your header file name .cpp to actually do the implementation. So you're just gonna copy the functions this side. You're gonna first put it this side. If you're gonna have a function, you first put it in your header, and then you come to your implementation. You put it here. Let me just zoom. And then of course we need to know. Don't forget the namespace in your implementation as well. Don't forget the namespace, forest space. Put everything inside the namespace as well. Here, like this. So, and also include the header file here also, because we need the header file here as well. So don't forget to include the header file in your implementation file, and don't forget the namespace. Those are the two most important things that you need, right? And then we are gonna now come here and we're gonna do the initialization part. Okay, so how do we do the initialization part? Initialization part, we basically need to make sure that our our game world. So basically, so let me just say here, we're gonna have game world, because we're gonna initialize game world, and we are gonna return that game world afterwards, right? So let me know if you're confused. I don't want to lose you. We're gonna have game world, and then we're gonna return game world. Do you guys understand? So now we're gonna do something. We're gonna do something here to manipulate the game world. Game world. We're gonna do something to manipulate the game world. What's that?
So I wanted to, can you please repeat it like the whole thing? I don't know, my network is acting up.
Oh, okay. Is it who's this? Is it Tumi?
Yes,
Who was that? Was it Tumi?
yes, it's me.
Okay, no problem. I'll repeat, right? So the initialization function,
Okay.
you're gonna have the header file for your initial for your definitions. Header file basically says that in my forest space, I'm gonna have a game world. I'm gonna have an initialization function, right? But then in the implementation file, you're gonna actually tell you're gonna actually say that my initialization function does the following, right? So we know now we have initialization here, and then we know right here that the initialization function will do the following, right? So basically what the initialization function, if you look at the function signature, it returns game world. What is game world? Game world is what's above here. I also did an example with a sum function that returns an integer. But now instead of us returning the primitive types, we're going to return like a structure, the game world. So it's going to take in rows, calls, chance, and map pieces, and it's going to use these values to initialize the game world and send us back our game world, right? So okay, so now let's look at the game world now. We know that we're going to initialize, we're going to return the game world. That's why I did say game world as like a variable. So this is the initial, I'm declaring a variable, declare game world, and then return that game world. Return game world. So now this can work. This is 100% correct. It can work, but the only problem is that the game world won't have any values. It will just be game world, but it won't have anything. So we're just gonna do game world, and then we're gonna return game world. It won't really have anything. So what should we do now? We should do the we should now start populating values or using these incoming variables or arguments to populate our game world. You have to say game world dot int rows is equals to int rows, because it's gonna come in from there. And now our game world is starting to have things inside. So now if we return, at least now we're gonna return game world with int rows coming from there, right? It's not yet complete, so to complete it we have to continue with everything else. Game world dot int calls is equals to int calls, and then game world dot int chance is equals to int chance, and then game world dot int map pieces is equals to int map pieces. We are not done yet, but at least we have our game world now. You guys understand? It has some things. It's not yet complete, but it has certain things. It has rows, it has calls, it has chance, it has map pieces as well. What else do we need? We need it to have the ARY world. Are you guys following?
Yeah.
Yeah. So ARY world is where we do what's this? Allocation. That's where we're gonna allocate memory. ARY world, we're gonna do memory allocation. And there's many ways to actually do this. I'm not gonna lie. But then what works, it's basically what you prefer as the coder and what you think makes sense. As long as it makes sense, don't panic. Don't try to look at the memo and be like, the memo is confusing and whatnot. Just keep in mind that whatever you're gonna do in programming, or especially in C++, as long as it makes sense, right? You are fine. It's fine. There's no reason for you to panic or anything like that, right? So now I'm gonna do initialization. Let me see how I'm gonna do initialization. We need to allocate memory. Allocate memory allocation. Are you guys comfortable working with pointers?
Not that much.
Yeah, pointers are something else. I'm not gonna lie, pointers are something else. I want to find an easy way for us to do this. To work with. I want you guys to fully understand pointers as well.
So again for the game world function, like don't, we don't include what is the array world in there.
We That's what I'm actually stuck on right now. I want to explain
Oh.
because these ones are easy. You see, this one you just say int rows equals to int rows, int calls is equals to int calls, int chance is equals to int chance. But the ARI world has 2 pointers. So I want to help you guys also understand how to actually initialize a pointer. It's called basically basically allocating memory, right? So okay, let me try and make it simple, like as simple as I can. Like I want to make it as simple as I can. Okay, so guys, I'm gonna go to main just so that I can explain a bit about pointers to you guys, so that you have an idea of what's going on. If I do this in pointer, right, a is equals to new int 10. I'm typing slow because I'm trying pointers. The pointer section is very confusing, and it's also not easy to explain, and it's also not easy to understand, but I want you guys to understand fully. If I do this, right, what I'm actually doing behind the scenes, I'm creating 10 blocks in memory on the heap, right? So how do I initialize each
Only
block?
time using the laptop.
How do I initialize each block? I'm gonna loop through. I'm gonna create a loop. I'm gonna say for int I is equals to 0, I is less than 10, I plus plus. You guys are not actually saying this. I'm gonna show you guys now what I'm actually doing. And then we're gonna access I is equals to, let's initialize each to 10. So this will have 10 things inside, right? 10 things in a not initialized. If I do this, I'm initializing it and I'm storing 10. So this is allocation, right? And then this is initialization of arrays. I'm talking about arrays and pointers. This is initialization. And I'm laughing because it's quite not easy to explain pointers. If I come again and I loop again 10 times, int I is equals to 0, I is less than 10, I plus plus, delete AI. This is deallocation. I'm just gonna make sure that it points to now. Okay. Now point. Who's lost?
I am.
Yeah. It's pointers. I understand. It's pointers. But what this line is doing, new, wherever you're gonna say new, there must be delete. What this line is doing, it's creating 10 spaces on the heap for us. So let me just draw this down. I'm just gonna draw this down because if you guys are lost, it's I don't want you guys to be lost. I want you guys to be on the same page. And I'm just gonna write it down. Just give me 1 sec. I'm just switching the pen. Okay. I want you guys to let me know once you can see. There should be a board somewhere. There will be a board soon. Just wanna write it down. So can you guys just take a picture of this? Just take a screenshot of this, or just keep it somewhere, because I wanna explain it and I wanna write it down on the board. Also the line numbers. Also take the line numbers down. Okay, gonna share my screen. Okay, let me know if you guys can see my screen. Can you see my screen? Can you guys see my screen?
Not at the moment.
Okay, it says here I'm sharing. It should be white. It should be white.
Yeah, it's not visible.
Okay, amazing. So what I was trying to show you guys, right? You see line 10. Line 10 says in pointer a is equals to new int and then square brackets 10, right? So what this does, it basically creates a space of 10 integers on the heap, right? It creates that space 1 2 3 4 5 6 7 8 9 10, right? And then if you want to access something at a specific location, just say a and then I. I can be a value between 0 and less than 10. So I can be mathematical. This is the mathematical expression. I can be a value between 0 and 10. So this is number 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6 7 8 9, and then obviously you can't have 10. You guys know it has to be less than 10. You remember how arrays work in C++. We can't access, there's no 10 because it starts from 0, right? So now when we look at the first for loop from line 12, right? The first for loop from line 12, we are basically saying that we want to start here. So this is the start, because I is gonna be 0 initially. Want to start here and want to end here. That's why it says I is less than 10, which is 9, right? So this line, so line 10 creates this whole thing, line 10 creates, and then line 12, the loop basically saying we want to start here and we want to go step by step. We want to go to this, like step by step, because it's a for loop. You guys understand how a for loop works, right? And we want to put 10 in each and in so line 14, where I do this, line 14 where I say ai is equals to 10, we want to basically put 10 in each and every one of these blocks, like this. You get it?
Yeah, I do get it.
Yeah. So so what is A now? A is basically the address of where the array starts. So A is basically pointing to this. You understand? When I said new, it created this whole thing and then it pointed to this, right? So now when we go to line number 14, where we are basically putting everything, we're basically saying we want to go to A at 0, A at 1, all the way until 9, and we wanna put 10s inside, 10, 10, 10, 10, 10, 10, 10, right? So now line 17, we're looping through again, right? We're looping through again. So when we're done, so we're gonna start, so with line let me just say line 12, we are gonna start here, and then we're gonna go all the way, accessing all the elements. So we're gonna be accessing all the elements, so meaning that we're gonna come here, put 10, come here, put 10, come here, put 10. You understand? Step by step. That's what the for loop does. Step by step. Put 10, and then put 10. When we are done, we are done with the for loop. So now line number 17, it's the same thing, right? Line number 17, we are basically now coming to visit again, but this time around we are deleting. Delete, 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 delete. And now A is no longer pointing to anything. A is like freed. So that they call it like to free the memory. Now A is no longer pointing at anything. It's just A, and then it's just gonna deallocate the memory like that. Are you guys following?
Yeah.
Okay, cool. Yeah, let's go back to the coding. Yeah, the pointers are quite confusing. I understand, but we will go in time. As long as you practice, you're gonna be okay. So I'm back here now. Can you still see my screen? Is it code now?
No.
Oh, let me reshare. Yeah, let me know if you can see my screen again.
Yes, sir.
Yeah. So that's basically how pointers are in a nutshell. Allocation, initialization, deallocation. Always remember this. It's basic. If you have a picture of that, let me see if this one. I doubt if this one will work. In given delete. It's not an array.
Sir,
Yes.
can you please go back to CPP? I wanna check like initialization of the game world. Yeah.
Okay. Cool.
All right. Thanks. Thanks, sir.
Okay. Yeah, just oh sorry, fix that code that I gave you guys. It was supposed to be, there was not supposed to be that thing that was there, this thing. So I just remove it because now it's 1D. I'm used to like 2D. So this is 1D. So for that one, just make it look like this, and then just put this down. If you are confused about pointers, don't overthink it. I'm gonna explain to you until you understand what pointers really are. Pointers are very difficult. I'm sure half of your class that don't really understand what pointers are, and it's okay because pointers are a bit complicated and they are only on C++. When you guys get to computer science 2, there are no pointers anymore. It's automatically done for you in Java. So let me go now to our initialization, right? So here we are. So we're gonna need a function that will do the allocation for us and return back something in after that. So just one sec. Not my notes. Yeah. So initialization function, what do we expect it to return? If anyone knows, for our ARY world, our allocation function. Sorry, not initialize. Our allocation function. What do we expect it to return? Anyone?
Doesn't
Just
it
just guess.
doesn't it like returns rows and columns?
Close, but yeah, not really. But like the data type. Just say the data type.
Characters perhaps.
No. Anyone else?
Can you please repeat the question?
What should the allocation function return? According to this, the allocation function basically allocates our 2D array.
Shouldn't it return the array?
It should, but what is the data type of the array? What is the type?
Integer.
Close. Integer is a number. I just showed you guys just now. Okay, so okay, let me ask let me phrase it this way. A sum function, what should a sum function return?
The integer, sir.
Yeah, because the sum is integer, right? So our
Yes.
our 2D, what is our 2D array? What is our rows and columns?
The grid.
It's a grid. What is a grid? What is the type of a grid? Data type. It's here, line 14.
Integer.
Integer pointer, right? Int pointer allocate. Because if it returns int only, guys, and here we're gonna come and say allocation. We're gonna come and say game world dot ARI world is equals to in let me say allocation, something like this. If I do this and this function returns an int, but here we have an int pointer point, it's not gonna make sense. It's like, okay, you're trying to assign an integer to an integer pointer point, right? Okay, cool. What should it take in?
It's parameters.
Yes. What are the parameters?
It's gonna take the rows and columns.
Yeah, perfect. So it's gonna take in int rows, then int columns. Okay. We could further say that it could take in whatever is gonna be at that cell, but for now let's just let it be empty. So here's our initial allocation function. Guys, also understand that whatever I'm giving to you now, this is not rocket science. It's whatever you guys must memorize. And when you go and write, have these things in your head. Like when you practice, make sure that these are the basics. You should have the basics. You know, have the basics out of the way. So allocation, I'm gonna copy this and then I'm gonna come here and then I'm gonna define it outside because I have to define it first. Remember, you have to declare it and then you define it, right? So what will the allocation function do? It will allocate the memory for us, right? So let's just work it out together. How are we gonna do allocation? Let me just help you guys out. In pointer because it's gonna return that, and then we just say, let's just say world or ARI world, doesn't really matter. ARI world is equals to new int pointer, right? And then it's gonna take in int rows. These are our rows. Then we're gonna loop through, because remember, we have to loop through in our rows, right? We're gonna loop through for,
Can I ask?
yes,
Where you said new int pointer int rows, sometimes they say int columns. Is it wrong to start with int columns instead of int rows?
It's not wrong, but it's gonna be, it's like your grid is gonna be upside down now. So instead of rows, you're gonna have columns, and instead of columns, you're gonna have rows. You're just gonna swipe the two. So if you look at the practical, I did mention there's rows, right? There's rows, and then there's columns, right? So what we are doing here on line 8, we're basically saying how many rows are we gonna have, right? How many rows are we gonna have? We're gonna have, let's say, 1, 2, 3, 4, 5, 6, 7, 8 rows. So we're gonna say we're gonna have 8 rows, and then when we loop, we're gonna go row by row. We're gonna go to row 0, then we're gonna do allocate columns, 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 columns. And when we're done, we're gonna go to row 1, column. So if you're gonna come here and say in calls, you are just basically gonna put everything in reverse order. You're gonna start with calls instead of rows, and then you see it's gonna it can work if you know your logic very well. But then I advise you guys to start with the rows instead. Do you follow?
Okay.
Alright, so int r0, and then r is less than int rows, and then not I, r, and then r plus plus. So now you now, as I mentioned, you're gonna be inside row 0, and then we're gonna do columns for row 0. So now we're gonna say for this one it has to be a r y world row. You see, now we're accessing the first row, the row 0, and then what are we doing at row 0? We are now doing new int, no start this time around. There's no start this time around. Now we are gonna do calls, right? So always make sure there's only a star. So these two stars, we used one, and then the last one doesn't really have a star, right? So now for each, we're gonna look through the calls now. C is equal to 0, C is less than int calls, C plus plus, and then ARY world RC. Because now we are accessing each cell. Now we are at the point where we're accessing each cell, and then we can just give it a value. What value do you want to give it? We can give it 0 for now. Let's say we give it 0 for now, right? You don't have to give it 0, but for now we are going to give it 0 because we want it to have zeros, right? And then we're going to return our ARY world. ARY world. Do you guys have any questions?
Can you please so does this part of the code like label the grid, or what is it doing?
Okay, that's a good question. So this part of the code initializes our array. Do you remember when I was drawing those blocks? I said int a is equals
Yes.
to new int. So this part of the code creates those those boxes for us. It basically creates the
Yes.
grid for us, and then it's gonna put zeros
Oh.
everywhere.
Okay.
You understand? So yeah.
Yes. So since I remember you also said at the beginning that when they have new, then you must say delete.
Yes.
So
We're gonna get to
so
that
where's
part.
the delete?
We're gonna get to that
Oh,
part
okay.
just now. Okay? Because there's allocation and then there's gonna be deallocation. Right? Deallocation.
Alright.
So your 5 marks here, you're gonna get your 5 marks, and then your initialization you did. So this is your initialization. We're not done with our initialization because we have to do allocation. So we're gonna come here and then we're gonna say game world.arr world is equal to allocation. Remember the data type of allocation, there's pointer here. That's why it can work nicely. Like there's no need for us to stress or anything like that. It's gonna work nicely. We're gonna pass in what is required. Int rows. Then right, so now we're done we're done with our initialization, we are done with our allocation. We have 10 marks already from this part right here. We have allocation 10 marks, the initialization 10 marks. We just haven't used them as yet, but they are there. We are done. So now we are gonna come and say deallocation, right? When we deallocate, we don't expect to get anything back. We just want to deallocate. right? It's like when you destroy something, you don't expect to get anything back from it. But when you create, you wanna get that specific thing. So I'm gonna come here and do void deallocation. And then what do I need to pass in order to deallocate the memory, right? Any guesses? We need to pass in our game world, because the game world is what is created, and when we deallocate, we want to destroy what's inside the game world, right? So take note of that. And then when we pass in the game world, we pass it by reference. We use this end here. Don't forget, you pass it by reference, because you don't want to pass a copy. You want to pass an actual game world. So I'm gonna explain to you guys what this end percent means, right? So let's say I'm a function. I edit names, right? And you guys have an ID card, that ID card that you have. And I'm a function that edits names on the ID card. How I edit names, you don't really care about it. All you know is that I edit names, right? So if all you know is that I edit names, you're gonna give me your ID and it's gonna say edit my name to something else, right? So when you put this thing here, you're actually giving the function your ID card, your actual ID card, right? But when you remove this, you are giving it like a copy, like a paper. You just print out a copy and then you give it a copy, and then I'm gonna edit on your copy, and I'm gonna give you, and then you're gonna have two versions, the one that is edited and the one that is not edited. So you must make sure that you pass by a reference, so that we deallocate the actual thing, not the copy. We don't want to deallocate the copy, we want to deallocate the actual thing. Are you guys following?
Yeah.
So that's how the n percent, that's what the n percent actually does. Alright. So now I'm gonna go to define my deallocation function in my headers.cpp file, like this. And then I'm gonna say, okay, how do I deallocate memory? Right? Any ideas? But then what I can tell you guys is that the code is the same. Whatever I'm gonna put on deallocation, when you go to write your semester test, is the same thing, just the exact same thing, just different naming. So what I'm doing so far, it's the same thing. There's no mystery here, nothing whatsoever. You just have to come here and look through the rows. You're gonna look through the rows as equals to 0. R is less than game world, because the game world will give us the rows dot int rows, and then R plus plus, and then we're gonna go again and say for int C. We're not gonna look through C. Remember I said you can't look through C because C is not a pointer. Only the rows are a pointer, right? So only the rows here are a pointer. So how can I explain this? So C has calls as an actual value, but rows don't have an actual value. Rows are still pointing to calls, like to a grid, so another array of calls. So let me not confuse you guys and explain much here. I'm just gonna say the code is gonna be the same, and you guys are gonna get this code. Just study this code as it is, and then you're gonna say delete game world, the ARI world, and then you're gonna put your R there. And then you're also gonna come outside, and then you're gonna delete ARI world. ARI world. We're gonna test these together as well. Game mode.
So will you send like the complete code after we finish everything?
Yeah, I'm gonna send everything to you guys. I did mention in the beginning of the session that I'm gonna send you guys the code so that you can study or refer to it when you are preparing. So yeah, this code will always be the same. It will never change. So you just need to look at it as it is. You get your full 5 marks, and then you have 15 marks. So here you're gonna have 15 marks. You're gonna have a 15 marks on this C9. You have 15 marks on C9, right? Maybe initialization is not yet completely, but we're gonna go through that one as well. But then here you're gonna have your full marks. So embrace yourself for what's coming, because it's what we did. It's the command line arguments.
Hey, before you get there, can you please just go back to the allocation part? I wanna see something there.
Okay.
Can you please explain the delete outside the for loop braces?
Okay, amazing. New. Do you see the new?
Uh-huh.
And then new again. We have two news. We have two deletes. Right?
So
The first new was for the rows. The second new was for the calls. So this one deletes for the rows, and then this one deletes for the actual thing. It's hard to imagine or to explain this, because I mean, like I said, with pointers it's a bit complicated. But then we have a game world, ARI world, right? That thing is a pointer. We have to first delete the first pointer, and then we delete the other pointer. The first pointer is the rows, and then the other pointer is everything else, right? So let me just see if there's a simpler way to explain this. Pointer. It has rows and it has calls. The rows are gonna point to calls. The thing is, it's even hard to imagine this thing, right? But then what it's doing here, we are deleting the two news that we have inside the allocation. For now, just keep that in mind for now, ne? And memorize how I've done this whole thing. For now, I'm gonna explain to you when we get time, in a way that I think we need like a pointer session dedicated to pointers. For you to fully understand what pointers really do and how they are different from a normal variable. So yeah, I'll explain to you this, but for now it's gonna be like this. We are first deleting the rows that are pointing to the calls, and then we're actually deleting the actual thing that has the rows inside. You understand? So yeah, I'll explain to you this sometime. So now let's move on to any questions before I move on?
No.
Okay, so let's move on to command line arguments. On this practical, they did say that they want so now we're covering, which section is this that we're covering C6. We're covering C6 now. So C6, the size of the environment, infection chance, recovery. No, this is the wrong paper. What was going on? Yeah, here. We're covering C6 now. So C6, we want the size of the environment, the chance of the towers getting destroyed, and then the number of map pieces are given as the command line arguments. Now we come here. We're like, okay, what do they want as the command line arguments? You look at your question paper for what they want, and then you write it down. You don't panic, you don't overthink, you just relax. You say, okay, they want int rows, right? I'm gonna get it somewhere in the command line arguments. So for now, let me just say 0, and then they want int calls. I'm gonna explain to you why I'm saying 0, and then they want int chance. Also, everything that they want here, it must be in your initialization function. Int rows, int calls, int chance, int map pieces. That's what you must put here as well. Int map pieces, because that's what they want. They want that, because where are you gonna use all these functions? You're gonna use all these functions in your main, and your main is gonna have the arguments. All right? Okay. So this is what they want, and then after I give them all these things that they want, this function will give me back game world. And then you come, you say here, okay, I'm expecting game world. Why is it not showing me anything? If you are typing on main and it's not showing you anything, just know that there's something missing, right? So what is missing? Can anyone guess what's missing? Why when I type it doesn't show me? Take a guess.
Perhaps the grid.
Nope, it's not the grid.
Is it the one where you put game mode in front of the array?
Nope, it's not that. Keep guessing. Keep guessing. Just guess. Guess.
Uh,
So okay, remember when I said when you have pencil, eraser, and a thing, you put them inside a pencil case. If I don't have the pencil case, I can't access those things inside the pencil case. So namespace is what's missing, right?
Oh, at the top.
Yeah, using namespace, forest space. So if I don't have the namespace, I don't really have the pencil case. And I can't take the things inside the pencil case. But now if I say using namespace, forest space, it means now, okay, now I have the pencil case. I just need to open the pencil case and get what's inside. So let's go continue. Game now, okay, now it's there. Now, okay, I can continue. Game world, and then game world is equals to initialization, and then I'm gonna pass in what needs to be passed inside the initialization function. So in this case, I need to pass in int rows, int calls, int chance, int map pieces. I close like that. So now my initialization function, when it gets called, it's gonna take in those rows, calls, chance, map pieces, and then it's gonna give me back something. Okay, let me explain to you why I did 0, 0, 0, 0, 0 here. I did 0, 0, 0 here so that you guys, when you are coding, right, it's always a good idea to initialize your integers. But what's important here is that I want you guys to be able to call your functions without actually worrying about where you're gonna get this value. You just know that you're gonna get this value somewhere, but then you don't need to worry about getting it now, because you want to code as fast as you can, and then you want to obviously finish as fast as you can. So let me say 10 10 for now on rows and calls, because I actually want us to see everything working. So I'm gonna do game world initialization, and I'm gonna do deallocation at the end, because I have to deallocate my world after that, right? And then I'm gonna run. If I'm gonna show you something that is very, very important, and most people tend to panic when this certain thing happens. I'm gonna show you, and you shouldn't panic. I said 10 10, and then I'm now gonna run this. Okay, I got what? 0 back, right? What does that mean? That means that the memory, the initialization was successful and the deallocation was successful. So I want to show you guys something, a common mistake that students make, right, that you guys are going to avoid. So let's say there's you see here, you guys are you did like a mistake. Instead here you said int calls. It's a mistake. Let's say it's a mistake, right? You did int calls by a mistake. It was supposed to be int rows, but you did like int calls by a mistake, and then let's say calls is 5, because it's not the same. So when you run, this is what's going to happen. Okay, hold on, let me see. Deallocation, calls. Okay, give me 1 sec. It didn't go as planned. You said in calls is 4. Let's say in calls is now more. Let's say in calls is 15. Let's see. Yeah, so this is what's going to happen. You see, your program will do this, and then it's going to exit with minus a negative number, right? What does this mean? If you run, every time you run your program, right, and then you see something like this, it's loading, until it says minus something, right? Minus returned and negative. Just know that there's something wrong. We are trying to access something that is not available, because this thing was going to run, and then it was going to go to number 15, to column number 15, and we only have 10 rows here. So as soon as your program does that, don't panic. Just know that, okay, it's either there's something that I'm trying to access that is outside the world. You understand? So if I come back here and then I do run again, you'll see that, oh, okay, initialization worked successfully, deallocation also worked successfully. I'm now sure that I'm gonna get close to 15 marks for my initialization and deallocation. We just need to work on the initialization part now.
So,
Yeah.
Can you please go back to the allocation function?
Okay, yeah, here.
Yeah, so every time we have to allocate memory, do we have to include all those for loops for in columns and in rows?
Yes, you have to include all the for loops. So how the for loops, what they do, the first for loop, it just goes through. Okay, outside, you see outside, line number 8, this one creates rows, right? But rows are just rows. You can just imagine a row as like something that looks like, let me see if I can draw. Where can I draw? Let's see. Yeah, let me just open Excel. Right, I'll just open Excel just to paint a picture so that you guys sort of like understand fully. I'm just gonna open Excel, and then so rows. So the first one will just create rows like this, right? So now each row points to columns. These are the columns. So now if you do, so the first one, right, it's gonna create row pointers. So these are the rows, 15 rows. So from 1 until 15 rows. When you access them, this is row 0, this is row 14. That's why we start at 0, we go until less than rows. And then this second loop inside, for each row, what we're saying is that for each row, line 13, for each row create 10 columns. So for each row, for this row, create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're gonna do it for all of them, and now we have a grid. And then basically here what we're saying is that put 0 in them. So now we're just gonna say put 0, and then for all of them, 1, 2, 3, 4, 5, 7, 9, 10, 1, 2, 3, 4, 5 until 15, we're gonna put zeros like this, right? Do you understand?
Yes, sir.
Yeah, so you do need both the for loops. So if we had something very complex, let's look at a 3D game. A 3D game has to go deeper. It's not just 2D now. We're gonna have another. So this would be X, Y, and then another Z for loop inside for the Z index. Because now it's 3D, it's no longer 2D. And the max you can imagine it will be very, very complicated. But yeah, that's basically how it is. So okay, cool, we are on our main function, everything works fine. We ran our program, it returns 0 after initialization and deallocation, it returns 0. We know that everything is smooth and it's working fine. Okay, so now what we're gonna do, we are gonna try and get these values now. These values we're gonna try and get them from the command line instead of a just putting them manually like this, right? Okay, yeah, here's the trick now. What do we expect to see inside ArgC? How many axes, how many arguments do we expect?
Isn't it that we are expecting 5?
5, yeah. Why does everyone else understand why 5?
So it's basically the one they gave us,
The
and
environmental chance and that first bullet point.
True. But so yeah, we were actually at the first bullet points. There's 1, 2 here. Here is 2 rows calls, 1, 2, 3, 4. So why are we expecting 5 args instead of 4? And also it also
Because of the
confirms here that
name
it's 4.
of the-
Yeah, what's that?
I remember you said because of the name of
Program.
the something.
Correct.
Oh, okay.
So now we're gonna come here, we're gonna say if argc is not equals to 5, because we want it to be 5, right? We don't want 6, we don't want 7, we don't want less, we just want it to be 5. What are we gonna do? We're gonna see error something. See error. You can just say I don't know how you guys standardize your error messages, right? But like I said, my C out and my C in, it might be slightly different from how you guys are gonna do yours. So just understand that it doesn't really matter how you do yours, right? So you can say maybe here incorrect args for now, or you guys can further say maybe incorrect number of arguments. Let's say incorrect number of args. If you are like if you have time and you are that student, you can just say here full stop, and then you just say here let me just also leave line here with space. You just say expected 5 and then received, and then you tell them how many did they send, argc, and then just say end line, right? And then obviously you're gonna have to exit the program with a code that we're gonna discuss. I'm gonna say for -1 for now, but I'm gonna discuss how we're gonna nicely put our code so that we see. So now it's gonna say incorrect number of args, expected 5, it received that number. So if I run this now, we expect to see our program fail to run, and you can see here it says incorrect number of args, expected 5 but received 3. You see. So also the message, guys, please make sure that the message you're gonna write it as your own. I'm just demonstrating how the program should run. So now it says expected 5 but received 3. So let's go and change the number of arguments. You go to project, set program arguments. Now let's say 10. Let's say the user enters more, and then you run it, still the same thing. It's gonna complain incorrect number of args, expected 5 but received 7, right? And then we are gonna now do the right thing and say, okay, it seems like the program doesn't really wanna run if I don't have correct number of arguments. I'm gonna come in and I'm gonna say rows. Just open it again. So I'm gonna say rows 10, calls 10, chance, let's say 50%, and then map pieces, say 5. Then now when I run my program, it's successful. It didn't complain, nothing whatsoever when it comes to the command line arguments. So also note that anything that has to do with when you run your program and then it says 0 here, that means your program executed successfully. So that's why here we're indicating -1 to say that your program didn't execute successfully. If I do 3 here again, we should see that it's gonna run, but then it's gonna output -1. Here's -1 here. That says that okay, something went wrong. Alright. So now let's come to our header files and sort of like fix this -1. Instead of us saying -1 here, we wanna put something that really makes sense, right? Something such as error argc or something like that. So we're gonna come here and then let me tell you the marks that we covered here so far. Forgot to mention the marks that you guys covered there. Command line, so appropriately overloading the main function. What they mean is 1 mark for this. Always make sure it's straightforward, guys. There's no rocket science. You study, you memorize, you try to write it on your own over and over again, you'll understand it. Handling incorrect arguments count, basically this, 1 mark. Use of supplied arguments, that's what we're gonna do now, right? We didn't cover that one, right? So we also covered error handling, use of conventional error handling techniques. This is an error handling. See error, instead of you saying see out, say see error where it's an error, and say see out where it's like an output. And then you would get your marks here, but then we just need to cover that one, the last part here, the last bit, which is the the named use of defined constants. It's also here. Use of named constants, 1 mark. So we're just gonna say here const in error argc, or whatever you want to name it, and then you can just say -1, or you can just say -2, as long as it's a value that indicates. So basically what's on the negative, if your program terminates and the return was a negative, that basically says that it's an error argc. So if I run it now, we'll still see minus and negative. So I'm just gonna run it. We're gonna see a negative because we see that the arguments that are passed 10, 50, 5, and then 3. This 3 is not needed. It's gonna exit with -1. And then now if I come to fix my arguments. Project, set project arguments, and then remove. We expect to see, instead of this error, we expect to see success, which is 0. There's 0. Everything is working fine. Okay, so far you are getting there. Maybe you haven't passed yet, but at least you are, and you haven't really done anything really. You just basically did what's required: the allocation, initialization, deallocation, the boilerplate, the coding style, the functional abstraction. I'll explain functional abstraction. We haven't really covered it. The C4 as well is covered. The menu system is not yet covered. We're gonna cover the menu system as well, and then the command line argument. So you've covered most of these competencies. You just need to obviously keep pushing and keep practicing to actually cover everything. And it's your project is quite simple as yet. It's not really complex, and I hope you guys understand everything that we did so far. You guys are following? Any questions? Any questions? Any concerns?
No question
Anything
from my
at all?
side.
For the deallocation part,
Yeah.
I don't really understand the
So,
function.
can you go back to the main function? I want to ask something.
Okay. Okay, wait, hold on. Before I go, let me just get the deallocation part, and I'll go to the main after. Yeah, what is it about the deallocation that you don't understand?
Under the for loop, like the square brackets after delete, why do we do all of that? Like, what does it mean?
Simple, just basically, it indicates that you are deleting an array. So I'm gonna show you something also now that I didn't show you. If I do this, if I come to my main and I do this, no, let me not confuse you guys. I'm gonna confuse you if I do what I'm gonna do now. Let me not confuse you guys. But I did delete here. I put the square brackets because this is an array. It's like, it's not one-dimensional array, it's a two-dimensional array. So that's why we had to put this the rounded the square brackets.
And then why for, like, after the for loop, why didn't you include the square brackets after the array word and say R?
After the array word here,
The top part.
here.
Yeah.
You wanted
Yeah,
that?
why didn't you include a square bracket with the R like you did in the inside the for loop?
Oh, okay. You're confused about these square brackets and these square brackets. Okay, cool.
Yeah.
Okay, I get you. So, let me just zoom in and go through bit by bit so that you see, right? So basically, this goes together. These ones here, they go together, right? And then this one is its own thing. Okay. So remember, I said we have rows and we have columns.
Yeah.
Yes. So the reason why here I did not include the square brackets is because I'm deleting rows. I'm not deleting columns. So if you look at the allocation, this is the one that has the pointer. This one doesn't really have a pointer. But then to explain how this works, the array is 2D, it's two-dimensional. It's like this. The grid is like this. So what line 49 does, it deletes rows. It deletes rows, right? So it deletes a row, and then it's gonna go to the second row, delete the entire row, go to the third row, delete fourth, delete. Right? You understand? So
Okay.
this line deletes rows. This line deletes the final thing that was pointing to the entire world. So this one, okay, let me just say this code here deletes Excel. It deletes our Excel, for example. It just deletes the Excel. But then before we deleted the Excel, we cleared everything. So now we have things inside our Excel file. We have rows which have, like, obviously columns and values, right? So we're gonna loop through each row and delete those rows one by one. Delete, 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 delete. All the rows. Delete the rows. That's why we are using the square brackets to access the specific row that we are deleting. Right? Then after we delete the rows, we delete the game world. We're just basically deleting our Excel so that it doesn't exist. It doesn't exist anymore. Gone. That's why there's no need for us. We don't only have one Excel. We don't have multiple Excels. But I hope that it explains, you know what I'm saying to you. I can't really. The thing is, it's hard to demonstrate because it's all in the memory. So this one deletes the rows, and then this one deletes the entire thing that was existing.
Okay, so you must delete what's inside before you delete the whole thing.
Exactly. Yeah. Basically.
Okay.
Yeah.
I get it.
So yeah, on the main function, what question did you have?
I wanted to ask, like, now that we have initialized the in rows, like with 10, in columns with 50,
Yeah.
like, where are we gonna get, at what point are we gonna get the link between, like, the input that we put on the command line arguments to the game world?
Yeah. So yeah, that's actually where we're gonna go to next. And then I did say it's out of 3 marks because I didn't cover that. So if you look at your where is it? Arguments, command line arguments. Use of supplied arguments. That's the third bullet that you are mentioning now. You just also take note of that. Use of supplied arguments is basically what we're gonna do next. We basically want to take what's inside, what's passed by the user, and want to output it. So let me show you guys something that I did say, that what's inside argv. What's the first thing that is passed? So if we don't pass any arguments, what is gonna be the arguments? Can anyone guess? If we don't pass any arguments to our program, what is gonna be the only argument? I'm just also gonna write here the
Argument of the program.
the name of the program. We are correct, right? So this is gonna be only argument if we don't pass anything. So that's correct. So if I come here now and then I delete the arguments, project set arguments, and then okay. So if I run this, we expect to see what's at 0, which is gonna be the name of the only argument, which is what I told you guys. It's gonna be the exe file. So this is just the link as to where the exe file is. You guys understand? So that's gonna be the only argument if you don't pass anything, right? So it means that what's at arg0 is the name of the arguments. What is at arg1 is gonna be our rows. What is at arg2? It's gonna be our calls. What's at arg3? It's gonna be our chants. And what's at arg4? It's gonna be our map pieces. Okay. So there's another catch that I want you guys to master and write down, right? What's inside argv? Argv stores strings. That's why it's char pointer. But this is also, you see, anything that has to do with pointers, I feel like I should have a session with you guys, explain fully what pointers are and what they do. So everything that is inside argv. So these past arguments. If I say 10, that means 10 rows, 10 calls, 50% chance, 5 map pieces. Everything will come into the program as a string. Write that down. It's gonna come into a program as a string. It's not gonna come into a program as an integer. It's gonna come into a program as a string. Everything, right? It's gonna come into a program as a string. So there's a function that converts to integers, right? You must define that function. It's the same. You must memorize it. It's the same function. It does the same thing. It just takes in a string and then converts into an integer. You understand? So always make sure that the function you write it that I'm gonna put next, you have it in your head. And also just like the get rent function, you must have it in your head. The function that I'm gonna write next is the functions that you should have in your head. It's not gonna change. It's gonna be the same. You should just memorize it and have it in your mind, right? So to int, the function is called to int, or convert to int, or convert integer. It doesn't matter what you call it, as long as the name that you're gonna use, it's gonna be the name that you are gonna understand. So what is the function gonna return? It's gonna return an integer. What is it gonna take in? It's gonna take in a string. It's gonna take in a string, str, you can say str input or str word or str anything, or let me just say str input, or let me just say yeah, str input. How do you spell input? Input, not input. Str input, and then it's gonna, so basically this function returns an integer, it takes in a string str input. The reason why we have this function, guys, is so that if you have a string input, you can convert that string into an integer so that you can store it here. So if I came, right, if I came here and then I did something like this, I did argv1, right? Sure, argv1 is the rows, but then this returns a string. So we want to take that string and want to make it an integer, because int rows stores integer. It only makes sense for int rows to store the integers. And then, like I said, this function, it's gonna stay the same. You just need to memorize it. It does the same thing, right? So int value or int input, doesn't really matter. And then you're gonna use something called string stream, right? So string stream, where is string stream? Where can we find string stream? It's inside the ss stream. It's inside, yeah. So hash include ss stream, right? So we're gonna have the string stream, and then you're gonna say ss. It's gonna get the input. So what the string stream is, if I were to think of it, what is string stream? It's like a pipe. So you put something into that pipe. So these arrows are basically saying, take whatever is here and put it inside that pipe. And then now, what we're gonna do, we're gonna try to take in what's inside the pipe, and we're gonna put it outside into our int value, right? And then this is just the basic conversion function. And then there's an error checking that also you need to memorize this one as well. Fail, if it fails to put, so let's say instead of a string, instead of a number, we had like a z as a string, and now we take that z, we put it inside the pipe, and now when we take what's inside the pipe, we put it inside the integer. It fails because now z is a string and we're trying to put a string into an integer, so it's gonna go here and fail. After it fails, we're gonna see error. This also, memorize this. Just say cannot convert, and then you can just output what you're trying to convert. So str input, cannot convert str input to an integer, and then end line, and then you exit the program. Now we have another exit code. You can say -2, because this one is no longer arguments, it's not error args, it's error conversion. And then you're gonna come here, gonna group them again. So const in error say conversion is equal to -2, named constant again, and then here instead of -2, I'm gonna do error conversion. And then if everything goes well, we're not gonna exit the program, we're just gonna return, don't forget to return the value, return int value. So now that we have this function defined, we are safe now to come here on our main and use that function. So instead of argv1, we're gonna say to int, then our string. So this will apply everywhere else. It will apply everywhere else, even here, even here, even here. But this one is not gonna be an argument number 1. It's gonna be argument number 2. This one is gonna be argument number 3. This one is gonna be argument number 4. And then remember what argument number 0 is the name of the program. We did that over and over again. So now if I come to my arguments, you see that this is 1, this is 2, this is 3, this is 4. And then 0, as we all know, is the name of the program. So how do we know that this works? Well, I mean, hopefully our code works, but we could test by obviously couting the rows, calls, enchants, and map pieces. We should ideally get all those values as expected. So I'm just gonna be dramatic, and I'm just gonna see out everything so that you guys see what's inside 1, what's inside 2. No, what's inside int rows, not 1. And rows, int calls, int chance, int map pieces. So if we were to see out, we expect to see all those values that we have here. We expect to see 10, 10, 50, and 5, right? So can you see that it's complaining? What is it saying? It's saying, oh yeah, I also help you guys debug. So now it's complaining. Can anyone guess why it's complaining?
Maybe not that it's expecting a string as like input.
So let me show you the console. Maybe you can guess again. Okay, can you see? It says error, string was not declared in this scope. Right? So the reason for that is because string is inside the IO stream. IO stream, and then you also need to use using namespace std. Yeah. Something cool that you guys might have noticed in programming or in C++, if you don't want to say using namespace std, you can just come here and say std, and then you have this. It's the same thing, but then you see, but then just to make your life easier, just say using namespace std. Anything that is green, I'm sure you have noticed, this is green, also this is green. Anything that is green tends to come from our std namespace. That's why it's green like this also here. So yeah, keep that in mind. And then now if we compile, hopefully it doesn't complain. Okay, yeah, it's not complaining, everything is fine. And then we're gonna see our 10, 10, 50, 5. Okay, yeah. Do you have anything to ask?
Yes, I wanted to ask for, I'm not sure, I think you were in the .h or the main.cpp file when you put this ss.fail. What does that stand for?
ss.fail, it's inside your int, your toInt function. So I explained that what happens, right, with the convert function, how the convert function works. Let me just make real world examples. So let's say we have what do we have? An ice cube tray. I can't explain it with ice cubes, but yeah, let's just say we have ice cube tray, right? When we have ice cube tray, we expect to get like a block that will fit into that ice cube, right? So here we have an integer rows. We expect to get an integer to store into that row. Do you understand? So if someone gives you a string, it's not gonna fit. So it's like if I give you a rock and say put it inside that ice cube tray, it's not gonna fit, right? It's not gonna fit. You only need like an ice cube that has the same dimensions, and so that it can fit inside the ice cube tray. So that's the same thing. Picture this as an ice cube tray, and picture this as expecting an integer. If you give it something other than an integer, it's gonna complain. So what's inside argv1 is a string. So we can't do something like this. Argv1 is equals to an integer rows. It's gonna complain because we're trying to put a string inside an integer. So it's not gonna work. I'm sure even if I try to compile, it's gonna say conversion from this to that doesn't work. So now if I come and define, so now what we did a function. We created a function that will take that rock and cut it so that it fits into the ice cube tray. So basically that's the toInt function, right? Now when I go inside my toInt function, it takes in a string, right? So in this case a rock, and then it converts that rock into the same size as the ice cube tray or the ice cube holder. So now what we are doing now, we are initializing where we're gonna store the value after we have really converted that value. And an SS stream is just basically saying that take that rock and put it somewhere in like taking that rock and put it, let's say, on top of a table. And then now when we try to now that we have that rock, we're gonna take that rock from the table and try to put it inside the ice cube tray, right? So it could happen that the way that rock is cut, it still does not fit. That means that that value is not an integer. So it's gonna fail. It's gonna come in here. So we're basically saying if ss.fail, we're basically saying that if we failed to convert into an integer, because we want this function to return an integer, right? We are gonna show an error to the user that no, we can't do that, right? And then we're gonna exit the program. But then if it succeeded, it's gonna work. So now let me show you an example of where it would fail. So now let's come here and let's say 10. This will work because this 10, it can be converted into an integer, right? And then I run this, it works, there's 10. But if I come here and say D, right, and then I run, it's not gonna convert D into, it cannot convert D to an integer. Do you understand why we have that SS fail? Yeah, so that's basically why we have an SS the SS fail. So we just want to make sure that the user, whatever they enter here, so if the user enters T here, it's gonna pass this first step, right, for checking how many arguments are there. It's gonna pass here because there were 5, but then it's gonna fail to convert that T into rows because T cannot be an integer. It's gonna say here cannot convert T to integer.
So, sir,
Yes.
for this, couldn't, let's say we were about to use that function of any two integer, will it like be efficient or what?
If what you use, which function? This one.
That's that neural function for any input variable and convert it to integer. Wouldn't that work?
Yeah, it would work for anything, for any string, as long as it's a string, and then you want to convert that string into an integer. You can even put 1997 as a string, it's gonna convert it. You can even put 2020, it's gonna convert it into an integer, and then it's gonna give you back an integer. It's gonna work for any input that's a string, as long as that input can be converted into an integer. If it cannot be converted into an integer, it'll just tell you cannot convert T to integer, for example.
Because for instance, isn't that one, let's say I put let's say a letter D, isn't it that one will convert it to what is it, that the corresponding value to in the ASCII
No,
table?
what you're talking about, it's the ASCII characters. ASCII, for those who don't know. I'm gonna have load shedding now, and I'm gonna have a backup. I don't know who still. There's someone also said they were gonna have load shedding, so I'm just gonna switch to the Wi-Fi backup now. So it might glitch for a while. Okay, can you guys still hear me?
Yeah.
Yeah, I was just switching to a Wi-Fi that has backup. So yeah, so when you talk about ASCII, for those who don't know what ASCII is basically characters. ASCII, it's characters. You mentioned something about the corresponding value. It's not gonna work this time around because
Your attention, please. The library will be closing in the next hour at 3 p.m.
Okay, so ASCII is this, right? So basically ASCII, it's like 32 is space, 65 is A, 66 is B, 67 is C, etc., etc. So you are asking if it's gonna say, if I put D, is it gonna take D and give me 68?
Yeah.
No, it's not gonna do that. It can't convert D to an integer. The reason why it's not gonna do that, I'm just gonna show you a simple example here. So let's say I have an int a is equals to a character. You see, this is not a string, it's a character. There's a difference. And then I say 65, right? And then I say a is 65. No. I say a is D. I say a is D. And then I see out A. I expect to see 65 here. I expect to see 65 if all goes well. Right? No, it's 68. Okay, in this case it's 68, right? So there's a so now what we are doing, instead of this, we are doing this. We're putting it as a string, not as an integer, right? I'm not sure if this will work. It will complain. Do you understand?
Yeah, I do understand.
Yeah, so it's not gonna work. Yeah, but that's ASCII. Yeah, for those who wanna learn about ASCII, you can just look at the ASCII table. Oh, it's 68. I don't know why I was saying 65. It was supposed to be 68. 65 is A, and then it goes all the way down like that. So, okay, cool. That's how the to-in function. That's why we have the if ss.fail. This do you understand, Kazmul?
Yes.
Okay, cool. So I can continue now. Okay.
So wait, just one more question. I saw somewhere where on the videos where he added, like, instead of saying string to what he put s2i. Is that just the name of his function, or is that like something else that you can put?
That's a very good question, actually. I'm not gonna lie, that's a very good question. So it all comes down to the functions that C++ has, right? C++ does have a function that converts strings to integers in its own library, right? So I think that function that you're talking about, let me see if it's inside the std. So I'm gonna go inside my pencil case. You remember when I said the namespace is a pencil case? I'm gonna go inside my pencil case. I'm gonna try to look for what's inside here. And I think the function that you are mentioning is stoi. So let's go all the way down, scrolling through all the questions, through all the functions that we have. Stoi. It's not in this namespace, but I do know the function that you
Doesn't that one belong to C library?
C library, yeah. It's stoi, right?
Yes, down to integers.
Yeah, C++. So yeah, it's this function. It looks like it's in std. I just don't know why I didn't find it. So it converts a string into an integer. So yeah, this function, you can use it, but I wouldn't advise that you use this function. So it's in std, stoi. Nice. It doesn't, yeah, maybe it's in the C library, but like, you can use that one, it can work, but then that's like, it's already defined for you, you understand? You can use it, but, or you can define your own function and use your own function. Just like with the C error, you can also make your own C error if you like and use your own. But then for functions such as to int, it's better you define your own, because you're gonna get more marks in terms of if you see you're gonna be checking errors, you're also gonna be using the name constants, and there's more marks here now. You see, so yeah, that was a good question, and you can do it that way. It does the same thing, but the only problem now is that you don't know how they define that function. Maybe they want you to have a string, or they have certain rules in their own function. So I wouldn't advise you to use that function. So yeah, I hope that answers your question, Kazmur.
Oh, okay.
Yeah, so yeah, you can also use that. Okay, cool. Compile, no errors, nothing whatsoever. We're still building fine, no issues. So I'm just gonna pause and ask anyone if you guys have any questions before we proceed. If you get anything at all. Is it difficult? Am I slow? Am I fast? What do you guys think?
Oh, the pace is just fine.
Oh, the pace is fine?
I'm okay with it.
Okay.
Yeah, no, it's fine.
No concerns, nothing whatsoever. Okay, cool. All right, let's now continue. Initialization, deallocation to int and allocation. You would have had so many marks all the way here. So now let's look at initialization. We're not done with initialization because what do we have? We have zeros. But before I do initialization, let me do display, because we have to display our world. We need to be able to display our world. Let me see if they did mention anything about displaying here. Nothing about displaying, which is wow, because you're supposed to display. So if there's no marks for displaying, how they going to know if things working? But yeah, displaying your world, guys. So once you have your world initialized, you need to be able to display it. So how are we going to display the world? Same thing, also memorize display, but there's going to be obviously a few changes which you guys must address. I'm going to come here now and just display. One sec. So we just also, so what do we expect display to return to us?
To the world, the rows and columns.
Okay, anybody else?
What was the question again?
What do we expect? What do we want display function to return back to us?
Isn't it that it's supposed to display those features?
True. It's supposed to display, right? It does no need for it to return anything, right, Nkazi? So display just displays and nothing happens. Like, I just want to see what's inside the world, and that's it. Just, if I tell you please display the world, I don't expect to get anything. I just want to see with my eyes. So it's a void function, and then it's gonna take in what is it gonna take in? The world, because we have to display the world. And then I'm gonna come here and define it. So it's above the allocation. So I try to match the same order as well. It's above the allocation, but the order does not really matter. I just try to match the order. So if I want to display, I'm going to loop through the world. Every time you display, you're going to look through the rows and then the columns, and you're going to display all the columns for each row. So for int r is equal to 0, r is less than game world dot int rows, and then r plus plus, and then we're going to loop through the calls now, because now we're inside the world, inside the rows. Now we're going to go inside the calls. C is less than game world dot int calls, C plus plus, and then we see out. We're basically going to see out what's inside. So we're going to see out what's inside our calls. So for now, what I want to do, I want to show you guys something, right? When it comes to display, also display function, memorize it. When it starts printing the calls, it's going to print the calls, and then it's going to go to the next row, it's going to print the calls. So make sure that when it goes to the next row, so when it runs so it's going to go to row 0. So if I open this thing side by side with the practice, it's going to go to row 0, print the calls, then it's going to go to row 1, print the calls, go to row 2, print the calls, row 3, print the calls. That's basically how the for loop works. I want you guys to know that after it's done printing the calls, we want to end line so that it goes down. If I don't end line, let me show you what happens if I don't end line after the calls. So let me see out a star for now. I'll just see out a star for now, but I'll fix this. So I'll just see out a star for now, and then I'm gonna come here, and then I'm gonna display. Then I'm gonna display what? Game mode, right? You're gonna see something. I wanna show you guys something. You see, it did display, but then it just printed in a straight line, right? It's not wrong, it's right. It's just that we didn't end line after each and every row. So after each and every row, so where does the row end? So the column ends printing, and then it's gonna go to row 1. It's gonna print, go to row 2, print, row 3, etc. So we want to see out end line after. So that we see rows, so that we see it as a grid. And if I run now, you're gonna see that we have a grid, right? So the grid looks like this. It has how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And columns it should be 15. So like as we did, we go here. 10 rows as we expected, also expecting 10 columns. So let's run again and see how many columns we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as well. Right? But then it doesn't look proper. What I like to do, what I usually did for my practicals or my tests, I just left a space after. So after I print, I just left a space, something like this, and then I left a space there. So left a space, and then now it's gonna look like this. See, now it looks proper. The sizes, it looks evenly distributed. So this is the display function. But instead of us displaying what's actually inside the world, we're displaying stars. I'm gonna fix that just now with you guys. Right? Okay, cool. Any questions?
Questions?
Okay. So now let's see what they say, what they tell us what's inside the world. The what's inside the world. Now we are coming to the initialization part, because we also need to initialize what's inside the world. Right? So these are basically the features. So what do we have? We have trees. You can highlight every square in the world contains trees. Now we are inside the initialization. They are telling you that the world is filled in the following order. Entities cannot occupy the same position in the world except where stated otherwise. Right? This is very important. So now they say every square in the world contains trees. Okay? So what does our square contains right now currently in our world? Does anyone know?
You said what?
What does each and every square in our world contains right now?
I think that it contains the character of a star.
No. Close, but not really. Anyone else? Let me go to my initialization function. Maybe it's going to help you guys. Allocate. Let's look at
So
allocation function.
what you're saying is, so what you're asking is, what does the grid contain?
Yeah. What does each cell of my grid contains?
I think it contains a 0.
Is it that
It contains zero.
contains
Yeah.
zeros?
Absolutely, because we set it to 0, and that's what it should contain. So the star, don't be confused with the star. We're not getting this really from the world. We just hard coded it, right? I could have just said F. It doesn't mean that my world has F's inside. Like it does. It's not like that, right? It's just that's just an output. It's just like a C out. This has nothing to do with the world, right? If we wanted to print what was inside the world, I was gonna come here, and then I was gonna say int, and then let me just say feature. Feature is equals to game world, and then .arr world rc. Now I'm accessing what's inside, you see, and then I was just gonna say okay, see out feature. So to see what truly your world contains, you would do something like this, and then if I run now, you will see that it contains zeros, right? It has our zeros. Here's our zeros. Now, if I come here on our allocation, and instead of 0, I say 5, right? And then I build again. You see, now we have 5s instead of zeros, right? So what's inside the world is basically what's inside after you allocate. If I do 10, we're gonna get 10s inside when we're now printing what's inside. You guys see that? Anyone who's lost?
You see there by your display function for your see out, in the middle you had a star. Oh, okay, no. Okay, now you have feature, and then you have those two things,
Space.
and then the
Why-
empty space inside.
Yeah.
Does it indicate that after each thing there should be a block in between?
Yes, so the space basically says that, okay, I want to have, is the space there. If I remove the space, they're
Okay.
just gonna like, they'll stack up on
They
on
follow
one
each
another.
other.
Yeah, they'll just basically look like, it's not gonna be like a grid, it's just gonna be like, oh, you see, like this.
Oh,
Yeah.
okay.
It's supposed to-
Okay.
Okay, right. So our world has 0, right? And then they are telling us that the practical is saying every square in the world contains the tree. That's a requirement. If this is a requirement, how are we gonna put a tree inside, right? We can just come here and say tree. But this tree needs to be defined somewhere because just tree doesn't really make sense. Even when I was typing, it was not suggesting anything. So I'm gonna come to my header file, and then I'm gonna have enum of features, right? I'm gonna have my enum, and my enum will have the features. Enum features, right? Enum and features. You guys might have noticed on the memo or something that to be similar to this, and features for our features inside, right? So what are we gonna have? They said we're gonna have 3. So let's say we have 3. We'll just put 3 here. Let's put a tower because we also know that there's gonna be a tower somewhere. Let's put a map, and then let's also put a tree map. I don't know what tree map is. I'm just thinking. Like last time we were doing revision with my students, we put a tree map. But then let me erase everything and let me do everything with you guys step by step so that you see. Okay, this is where these features came from. Let's look at our features. So every square in the world contains trees. Highlight trees. Each row in the world area has a charging tower. Highlight tower. Allocated in a random column. Charging towers override any trees in that location. So since they said that each and every square has trees, they are further telling us that the charging towers are going to replace the trees. The command line defined map pieces. Where are the map pieces? Highlight map pieces are scattered randomly throughout the world area. So now we have discovered a tower, and then also discovered a map piece. Okay, 3 things, right? Are scattered randomly throughout the world area. Map pieces are initially hidden and do not appear. Map pieces cannot be placed on top of each other or on charging towers, but can be hidden below a tree. Okay, which means they can also be on top of the trees. The drone starts in a random row in any one of the last. So we also have a drone, which I'm assuming is gonna be our player, and then the drone flies. This is just the logic. The drone starts with a battery level charge, right? So also this is another thing that is important. This one here, the battery level, battery percentage. So when we're doing our initialization, we must accommodate everything that they mentioned here. And whatever is gonna come next, just to give you guys hints, these points I'm gonna do them with you guys, but do not memorize these points. Just understand how to apply logic, because they are gonna come as these points, but they're not gonna ask you the same exact question. You guys understand? It's not gonna be the same exact question. It's gonna be different. So make sure that these points that I'm going through now, you guys understand the logic. I'm gonna help you guys understand the logic, so that when we do the thing, when you guys go to your exam or your semester test, you already understand how to do the logic. So for now, I'm gonna ignore this part about the drone. We're gonna focus on the first 3 bullets: 1, 2, 3. Right? Okay. So let's look at the code now and the question paper at the same time. Every square in the world contains trees. right? 3. Every square contains what? 3. You see, if it does this and it's yellow, just know that, okay, this is valid, I can use this, it's an enum. There's a tree, right? So now we know that we're going to have a tree, and also with enums, this is going to be 0, this is going to be 1, this is going to be 2, because that's how enums work. It assigns the first value to 0, then it assigns the first 0 to 1, and then it assigns this to 2, and then etc. going forward, etc. Or I can just say n minus 1. So yeah, understand this with enums. So tree value is going to be 0, then the tower is going to be 1, and then the map piece is going to be 2. If I had something else, if I had another enum, for example, enum x, let's just say nx, enx, and then I had a here. I had a, and then I had b, and then I had c. What is the value of c?
It's 2. It's 2.
Yeah, definitely. It's 2. So yeah, that's how your enum will work. So me saying 3 here is the same as me saying 0, but we just use 3 so that we don't get confused. So now I'm gonna come to my map, and I'm gonna, let's first define the features, right? So after you do your enumeration features, you can also do your char features, which basically, what features do they map? It's like they're a map to your enum. So 3, we know that it's gonna be 0. Here. So here we say, what do we want the tree to be? For example, we want the tree to be T or X. What do you guys want the tree to be? What symbol do you want the tree to be?
I think T is fine.
T, ne? And then we're gonna, for tower, what do you want the tower to be? X.
Can't we just have the tree as X and then tower as T?
Yeah.
Okay. And then what do you want the map piece to be?
Star.
Okay, star.
Star.
Okay, cool. So now that you have these things here, right? And then let's say you now come and you say, okay, let me introduce something. Let's say we introduce something called X, right? You must understand that this will also needs to change. If you don't change, then things they no longer make sense. So so this is called a mapping. This maps to, so X mapped to tree, and then T mapped to tower, and then star mapped to map piece. If you come now and introduce something, now things change. Now X maps to X, T maps to tree, and then star maps to tower, and then map piece doesn't have anything. So you would also have to come here and map something out to X, and then you just say, so let's say S for X. So now let me just delete everything and go and make sure that is 1, 2, 3 things. So 1, 2, 3. That's why I also have 1 and then 2 and 3, like that. Okay. So and now this is going to help us when it comes to the display function. So if I now come to my display function, where's my display function? Here's my display function. So instead of me doing that see out and then feature, and then this, what if I did see out and then I did this? So let me just say features, and then I did feature, like this. Do you guys think we're gonna get trees? What do you guys think? Do you think we're gonna get X's? Just use that knowledge I gave you now about this. Then let's go back to this. Is the program gonna work? Is it gonna crash? Are we gonna get trees? What's gonna happen?
Game 1. more than any.
I highly doubt you're gonna get one.
Oh, you highly doubt. Why is that?
Like, isn't that inside like the feature it was supposed to have like the look what again it was supposed to have, let's say it's for a feature, if you wanna display trees it was supposed to have at least like what is have 0 there for trees.
It was, but like, what's are you guys are you following what he's saying?
No.
He's saying we're supposed to have 0 for trees, right? So okay, what's inside? Okay, let me just try and explain everything again from scratch. What is feature according to what you see on the screen?
It's an interest.
True.
Feature is
Yeah, but what is it like in terms of the game? What is it? What is feature in terms of the game?
It's the grid.
Yeah, it's what's inside a cell in a grid, right? So
Yeah.
what's inside features so far is that we have trees everywhere. You understand? So we stored trees when we initialized inside. So now when we do this, we are trying to access what we stored. You guys understand?
Yeah.
Yeah.
Yeah. So feature is what's inside a cell, one cell in a tree. That's why I accessed it using RC. It's gonna go to row 0, it's gonna go to column 0, and then it's gonna give me what's inside. Right? So
Okay.
now I'll ask you guys, will this print out our trees?
I think yes.
Okay, anyone
I think
else?
so.
Anyone else with a different opinion? Don't be scared. Just it's okay. Let me just ask one by one. Guys, what do you think this thing will print? Because I want you guys to understand this fully. What I just did here. I want you guys to understand fully this part. Right? So, okay. Let me help you guys out. So, guys, if I do features, and then I do 3, it's gonna print out X. If I do features and then I do tower, it's gonna print out T. And then if I do features again, and then I do map piece, it's gonna give me a star. Do you understand? Maybe you are confused by the syntax of accessing what's inside these features array. Do you guys follow?
Yeah.
Yeah.
We do
So
see.
now, what's inside our world so far?
Yeah.
Trees, right? Now that we have trees inside our world, and then we come here, we say feature. We're trying to access what's inside. This will give us back a tree. Now we want to see out that feature. It's gonna give us a tree, because tree is 0, so it's gonna come here and match this, and then it's gonna print it out. You guys follow?
Why do we still have like those in
Your attention, please.
what sort
The
of
library.
quotation marks for like after the feature then?
Here.
Back to the CPP. After the feature, why do we still have like those things for characters? Meanwhile, like we can just see out the features.
So this one is for space. I'll show you now the difference between
Oh.
this and that. You see. So yeah, this
It's
one
for
it's
space.
confused. It's just for space. Don't worry about this one. It's just like for that space in between the cells, right? So like let's run the program. Hopefully it compiles. Can you see what's the... So it's compiled, and then let's run it. There's our trees. Are you guys following?
Yeah, yeah.
Okay, so now let me
Yeah.
show you something now. Let's come here now and let's put a map piece, a random map piece, right? I'm gonna put a map piece ARI world and then RC. So pick a random row and a random column. Let's say 5 and 6. Let's say 5 and 6. I put a map piece there. I'm not going to change anything in the display function. It will know when it comes here, because when it looks for the feature and there's a map piece, this is not going to be a tree anymore. It's going to be a map piece. So we should be able to see at least one star somewhere here. Here's our star. You guys get that? Which is
So it's replacing the tree with a tower.
so you want me to
The
place
tree with the matches.
you want me to put a tower instead?
I meant to say like it's gonna replace the tree with the map piece.
Yeah, because initially there
Okay.
was a tree. Now we came and we put like a tower. In this case, there's a tower. There's our tower there.
Okay, so what if like you say any random column and row without mentioning like any random?
It's gonna generate a random row and a random column. It's gonna put that thing there.
Okay.
That's the logic, and also we're gonna get to the generate random column function just now. So are you guys following? Are you guys still fine? Anyone with any issues, concerns so far?
So whenever like it's specified which you need to place it in a certain row and column, then that's where like we query it with just making a feature inside a square bracket. But then if it's placed random, you're gonna use the random variable to place it.
Definitely.
Okay.
Yeah. So yeah. Okay. Now let's see what we are looking at now. Drone. Okay. Now we covered this first bullet here. Okay. So we're gonna need to cover obviously the second bullet. So now I'm teaching you guys to apply logic. Now it's all a matter of like logic, like basically you now know how to create a grid, how to initialize everything, how to take in arguments, and how to display your grid. Now it's all about applying logic. So just 1 sec. I need to send a message. Just 2 seconds. Okay. Back. Okay. Yeah. So now we are applying logic. Now it's a matter of if they tell you to for example. Now this is like real life. This is where you like okay the difference between school and actual real life and stuff. So now it's all a matter of you using your understanding of what you have learned so far, what I've taught you guys so far about the grid, how to put something inside a grid, how to display the grid, and obviously after all that we have done, it's all a matter of now you apply logic. Now we're working together and we're applying logic. Even when the exam comes, these parts are gonna be different. These bullets are gonna be different. They're not gonna ask you the exact same thing, but the way in which they're gonna ask you, you're gonna use what we're gonna learn now to apply it to the semester test too. Okay, cool. Now let's go to our initialization. It's not yet done. Let's go to our initialization function, and then we see what we did. We initialized the rows, we did the calls, we did the chains, we did the map pieces, and then we also did the allocation, which gives us our grid. So now it's time to do every row in the world area has a charging tower. You see, that's like English. Every row has a tower, has one, and they even said has one charging tower. So here, every row has one charging tower located in a random column, right? Random column. What are we gonna need for a random column? We're gonna need a random number generator function, and then also the charging towers override any trees in that location. They're just saying that if we generate a random column in the in that row, and then we find out that there was a tree, we are gonna overwrite it. Okay, so let's all look at this second bullet, everyone, and let's try to work through it. I don't want to give you guys, I know the code is a memo, but what's the point of us looking at the memo if we can use our heads to sort of like apply this so that because when we're writing there won't be any memo, nothing whatsoever. So how would we approach this? How would we approach this? Anyone?
Each row in the well has one charging tower located random.
Before we proceed, let's just define our getRand function. Do you guys know that function, right? Yeah, that one is given. You must always keep it in your heart. It's not gonna change. It's the same as the toInt function. It's not gonna change. It's gonna stay the same. We're gonna do assertions after. I'm not gonna assert it for now. Plus 1. It's gonna return an integer. Okay, any questions?
No questions so far.
Put it in your CPP, and then let's have it again here. Yeah, so no questions. Everyone knows how to define this function, and it's gonna be there. It's gonna be there. You must just know it. Just memorize it. Memorize this function. Also this one. They are gonna be there. Deallocation will be there. Memorize it also. Allocation will be there. Memorize it. Display. Memorize it. Initialization. That's where you're gonna apply some logic to it. Okay. So now let's go to our initialization. So I'm gonna do it with you guys. I'm gonna try and explain to you how I would do it, and then hopefully you guys understand and you don't cram what I'm doing. You sort of like have an idea as to how I'm gonna do what I'm gonna do now. Okay. So they're telling me that every row in the world has one charging tower allocated in a random column. Charging towers overrides any trees. So I'm gonna come and say, let me just say place features. I don't know, I'm just gonna call my function place features, void place features. I don't expect it to return anything. Game world. Game world. And then so I just wanted to place towers in each and every row. So let me say place towers. Actually, I don't need to say place features. Place towers. Right? When will place towers happen? Place towers will happen as when I'm doing initialization. So here, after I did the allocation, remember you cannot place towers before you have allocated memory, because before line 41, guys, there's nothing. We don't have anything at all. It's blank. After line 41, we have now trees. You guys understand? So now I'm gonna place towers here. I'm gonna place towers, and then I'm gonna pass in the game world. I'm gonna pass in this game world here. So now for defining the place towers function, I'm gonna come and define it. So I'm gonna walk. Guys, please pay attention to what I'm gonna say next. It's not gonna be the same for your test, it's not gonna be the same for your practicals. It's just you basically now applying logic, right? So how am I gonna place the towers? They told me that each and every row will have a tower. So let me just open Excel again so that you guys follow along with me. So let's say a tree is 0. So a tree is 0. I'm just gonna do this. Copy this, and then I'm gonna have a grid. I'm gonna have zeros, right? So now what they're saying is that each and every row must have a tower in a random column, right? In a random column. So basically, what is a random column? A random column, it can be anything between this and this, right? So this is column 0, this is column number of calls minus 1. So how am I going to place a random tower everywhere here? I'll have to loop through. We need those 2 loops to loop through. So let me do the first loop. For int r is equal to 0, r is less than game world dot rows, int rows, r plus plus, and then okay, now we are at row 0. We also need to go, this is row 0, right? We also need to go to column 0, because where they overlap, row 0 and column 0, where they overlap, it's that over there. This is row 0, column 0, right? And this is row 0, number of columns minus 1. So now I'm gonna loop again, the second loop, and c is equals to 0, c is less than game world dot int calls, and then c plus plus. So what did they say? They said that just to show you something, they said that each row has 1 charging tower located in a random column. So the reason why I have 2 for loops, I just want to show you how traversal works. What is traversal? Traversal is basically saying that for row 0, so the first for loop will come to row 0, and then we're gonna loop through the columns, so from column 0 until the end. So it's gonna do this. So the program, how it's gonna work like this. So the first for loop, row 0, it's gonna do, when it's done, it's gonna go here, and then it's gonna do, and then like that. That's how it's gonna, that's what these 2 for loops are doing. So instead of us having 2 for loops, we said we only wanted 1 charging tower in a random column. So there's no need for me to go to do this. I can just come here, get a random column, place it there like this, random. Come here, place it random. Come here, place it random, just like that, right? So now let's remove the second for loop, because we're only gonna do for each row, we're gonna place it in a random column. How do we generate a random column? Anyone?
Sir,
Yes.
isn't it supposed to be put in a grid whereby the square bracket, right, for row, it's gonna be get rand between I don't know how many number of rows you chosen for your command line,
Definitely, yeah.
and then number of the square brackets for number of columns is the number of in columns minus 1.
Yeah, so int, we're gonna say int random call, right? Because we want a random column, right?
Okay.
For each and every row, we want a random column. So we're gonna go to row 0, and then we find a random column. So we get rand, and then obviously then the call will start from 0 until calls minus 1. So 0, and then game world.int calls minus 1. I can even just call it just int call, it's fine. I don't have to say int. So now we have rows and then we have calls, right? So now let's go and say game world.ary world for that r, and then for int call we're gonna put in a tower because it's a random column. Are you guys following, or you guys are getting lost now?
Oh, sir,
Yeah.
is it fine if, like, instead of introducing that integer in column, we just say get rand between 0 and in columns or
You
minus
just put
1?
it here.
Yeah, just put it in once.
Absolutely, it's fine. But now you see, if there's like an error, they might subtract marks for what's this part, naming of variables, right? So you must name all your variables. Even this one could work. It would, like most of the things here, we could just, like, shove them in one thing and not really have variables. But it's good practice to first define it, and then you put it there, and then you just now plug it there, so that if maybe, for example, they change something about in calls or anything, you can easily just remove it and replace the function with something that they changed it to. You get?
Okay.
So yeah, it is fine. It can work, but good practice is for you to have it somewhere and then you use it.
So if like we to have like multiple what's this? Multiple towers placed, let's say 2 placed in each and every row, how do we go about it?
Do you want? So you would repeat this code, right? You would do this. Obviously, you can't declare it. You do this, and then you just repeat the code, and then generate another number. So for that row, generate 2 numbers. I'm gonna also demonstrate this. Generate another number and then place it. As simple as that. So let's see if this one works. Hopefully it works. Okay, it does work. Each and every row must have T. Here's the first row. Does it have T? Yes, there's T. There's the second row. Does it have T? Yes, there's T. There's the third row. Does it have T? Yeah, all of them. They all have towers. All of them, right? So to answer that question for the second one, if we were to generate another number, there's something that I want you. I'm sure you guys are not aware of it. I'm gonna run this program again. There's T there. When I run it again, there's T there. When I run it again, over and over again, right? Why is it that our T's are in the same positions? Why are they not moving randomly?
It doesn't take back to the fact that we haven't like introduced that srand time function.
Correct. So we need to have srand. After you do your generate random function, have the srand and then put this time is not put this function, call this function, and then also where does srand come from? It comes from the C time. Don't forget this. Include C time. srand comes from C time. You must include the C time as well. And then I think the namespace, there's no need for namespace. It comes from there. So let's run again now. Yeah, there we go. We have now T is in a different position. And then if we run again, now T is in a different position, right? Are you guys still following? Kazimala, are you still fine?
Yeah, no, it's still fine.
Okay. I had the library will close at 3, right?
Yeah.
Yeah, no, I'm just gonna move.
Yeah, we're gonna take a break. I feel like we should take a break and then we can continue after hours. What do you guys think? You guys wanna continue or you wanna take a break? What do you suggest?
I think
Okay,
break
break.
will do because like we need to digest more. Maybe try to go to whatever that we are now.
Definitely. Yeah, let's take a break. What you guys can do for me, go to, we are looking at initialization for now, right? Just try to also redo everything without looking. If you feel like you get stuck, I'll send you guys this paper. If you feel like you're getting stuck, copy a bit, but don't rely much on this. You must rely on yourself, with the ability to do this by yourself. So like, yeah, to answer your question of how do we generate now 2 towers instead of 1, we can just come here and we generate another number, we put it there in a random thingy, and then we run it again. Now you'll see that we are gonna have two towers. 1, 2, 1, 2. Most of them are gonna have 2. This one has 1. Let me explain why this one potentially could have 1. It's because it's possible that we generated the same call for this row, so it just put it there. But then most of them have 2. You get? It's logic. Yeah, this is where you apply logic now as to like, oh, how would I do this? How would I do this? Once you understand the green, applying logic should be straightforward and should be easy. So we're gonna take a break at 3, and then we're gonna discuss.
Can I ask a question?
Yeah, no problem. Yeah, what's that?
Can you go back to SRAM?
SRAM.
Yeah. What's the difference between putting 0 and null pointer?
Quite a good question. There's no difference. So you know what goes inside this time? It's a seed, right? Like it's a seed. What is a seed? A seed is to say that seed. Let me see what a seed is. Seed. So the difference between putting a 0 and a null pointer, there's absolutely no difference. It's just, because like the value that goes here is like a seed. So if I put in like 200, right, as a seed, let me just compile it, invalid conversion from int to int pointer. How do they define a seed? I don't know how they define a seed. From int to time t. Okay, 0 does work. Okay, I think I'll help you. Also, I'll assist you with the topic of seeds. But actually, a seed is like saying that I wanna run a test, but I'm gonna be generating random numbers. So if you are generating random numbers, you never know what the value will be, right? But with a seed, you basically know that okay, it's gonna generate. If I give it 5, it's gonna give me a random value. Let's say 20. Every time you give it 5, it should give you 20. So a seed is basically used to run tests in a sense that you can expect certain results for your input. So 0 and null pointer, there's absolutely no difference. But then that we'll cover when we dwell into like seeds. There's no need for you to like really understand. You can put 0 or null pointer, it's the same thing. But then you can see here, if I hover, you see that it says here time. Where is it? Time. Okay, 1 sec. Now. Wait. Okay, it's not showing. But yeah, there's no difference whatsoever. You can use 0 or you can use null pointer. It's the same thing. I'll also explain. Just write that down. When we cover seeds, you guys are gonna do seeds next semester, I think. You're gonna understand why they have null pointer and why sometimes they have like a seed. So yeah, any questions other than that?
No question from my side.
So I just want to ask, so if we're taking a break now, what time are we going to continue?
What time would you guys like to continue? Because I'm sure you're gonna be leaving the library for those who are in the library, and you'll need to find another place or anything like that. So, and eat also, because I mean, I'm sure you guys haven't eaten, you haven't done anything. So, just estimate for me and let me know when you guys, and also check your load sharing schedule, and then let me know when you would ideally like to continue. Because you also need to revise.
The library.
So, what time do you guys want to continue? Or you're gonna text me on WhatsApp, and then we're gonna find what's common for everyone.
Okay, that's
I
fine.
think that's bad.
Okay, amazing. Yeah, go practice what we did so far, guys, and make sure that you can do it without looking everything that we did. And then when we come back, we're gonna cover the rest of the movements and everything else. But it's basically everything else is just basically logic, right?
Okay.
So yeah. We'll chat later, guys. If you have any
Okay,
questions, you
then.
can just remain behind and ask me.
Alright, no, I just have so it's like when we're estimating, it's like 30 minutes or like 1 hour, or so that I make sure.
It could be 2 hours, it could be 3 hours. It's all
Oh,
up to you
2
guys.
hours.
You can discuss. Yeah, it's up to you guys. Just
Okay.
you need to practice, and you also need to eat and do other things. So just let me know when you will be ready to come back.
Okay, no problem.
Okay, cool. I'll send you guys the project so far so that you can have a look at it.
Okay.
Okay.
Okay, cool. Cheers, guys. Anyone who has questions, just remain behind and ask me.
So I wanted to ask, like, how do we check? Are we maybe gonna still create a function like how to check if the player is moving like inside range of like what's this game world?
Oh, okay. So that one is quite easy. I'll just try and ask you the logic part of it, right? Which rows are available for the player to move in terms of like the world? Like, so let's say the player has like a row is going to, let me open Excel here, right? Which rows are available for the player to move in? Which rows?
Are you still there?
Remember, rows is going down. Like when I say rows, I mean going down. Like which rows? Like up and down.
You have your what's this your mic there? It's mute. I don't know why.
Oh yeah. I forgot. I'm on mute. So yeah, in terms of player movement, right? Can you hear me now?
Yeah.
Yeah. Which rows can the player potentially move to inside the world? It's 0, right? You agree they can go to row 0.
Mm-hmm.
And then they can also go to the number of rows minus 1.
Oh yeah.
You remember? And also the columns, the same thing, from 0 till the number of rows minus 1. So how do you know that the player is going to move to the right thing? Is you validate if they give you row and call RC. You must make sure that RC is, that R is in between 0 and R minus 1, and that C is in between 0 and C minus 1. You get it?
Yeah.
Yeah, that's how we're going to apply. We're going to apply the logic when we come back, all of us. Don't worry.
Okay, thanks.
Yeah. So I'm just going to take a break. You can just text me, and then we'll continue. Meanwhile, I'll just send you guys this practical on your WhatsApps. Is that fine?
Yeah.